My name is Ravi, and I'm going to give my introduction a bit later, if hopefully that's okay with everyone, because it would make more sense, I guess, towards the end. That's what I wanted to say. Today, I wanted to talk about a topic which I think sometimes gets overlooked in machine learning, is the hidden technical depth in machine learning, and I will try to showcase how me and my team has tried to kind of handle it. So yeah, let's get into it, I would say. So let's start with a story, right? Like, stories are always nice, at least for me. So let's start with a story, basically a story of me, a little early in my career, I would say, where I joined as a data scientist at a subscription based company, and I was very excited. To be honest, I was a bit overconfident, and I didn't knew too much. So but I was very confident, so and I was tasked with this churn model, which is very classical thing. So I was very confident. I was like, yeah, I know all the algorithms, I've worked with them so much, it should be a easy thing. And I mean, I could produce result very fast, get onto it with quickly, and yeah, maybe impress my boss at that point of time. And yeah, and it should be easy for me to just like create something, get it running, and maybe as I move forward I can streamline it, make it better. And I was so excited just to start with it, right? When you're new in career, you want to do those things. So I started where everybody would start, like my trusty Jupyter notebook. That's where I started with my data analysis preparation, did all the mugging with the data and everything, data preparation. uh, I was like, I know there is an imbalance in the class, so I was taking care of those. So the basic things which you encounter in the machine learning, I was like, yeah, I can handle those. I did the model training, I did the validation, and I was like, yeah, this looks good. And I was like getting happier and happier. uh, and then the question was like, can you put it to production? I didn't know much, but I looked around. I'm like, yeah, sure, I can do that. So what I did at that point of time was something like this, where I was, and this were like manual steps in a Jupyter notebook, where I was extracting my data from our database, doing all the preparation, training, evaluation, all of those in Jupyter notebook. Now I was like, I have to put into production. So basically, I used my trained model, the model I was very happy with, which had all the good score. And then I looked up online, and I was like, maybe I can, because we were on AWS at that point of time. So I was like, maybe I can use Lambda, which was like new and exciting thing at that point of time. And I was, so what I did basically was create a Lambda function using the runtime, which is at that point, I think it was scikit-learn. So I used that runtime to support it, and wrote everything, the handler function for it in Python. And it was, at that time, I was very proud of it, because uh, it was pretty good for me at that point of time, where it could react to an event, get the model file, deserialize it, make it into a model object, use the data which was sent by the event object, and produce the prediction and serve it. And I was like, damn, I'm good. Like, you can see where I'm going, right? I was so clueless at that point. So I was like, yeah, my code is in production. Maybe I can move to a different project. I already put it into production, so it should be nice and fine. And yeah, everything is automated, so I don't need to do anything. I can maybe start with the segmentation project I wanted to do for some time. And that's where the thing started not looking good, right? uh, I spent a lot of days drinking a lot of coffees. I don't know how much caffeine I had in my system at that point of time, but the very first thing which came like to me is like, I got some feedback from the business. I went and I tried to change some feature, because we had a plan which changed. So we had two-tier plan which changed into three-tier plans. I wanted to change the feature, and that changed everything, because as you know, in machine learning, you change anything, you basically change everything. And if you look at the core of machine learning model, it's basically a machine for mixing different signal to predict something. And when you have so much signal mixing, each signal is kind of dependent upon each other. So there is no they are so interdependent, there is nothing which is totally independent. And that's commonly known as entanglement. So that was the first time I saw that. uh, I was getting over that, and then I was like, oh, I have so many junk feature because I tried so many model, and I guess some of you might have seen where you create like 10 different version of your notebook where you try different things, and sometimes some of the old junk feature which might not be that valuable gets into your model, and now you're like not sure where you did it, why you did it, and and the whole data dependency, why I added, which table it's coming from. So that was another thing. I was trying to figure these things out, and then I realized, okay, I did change something in my development pipeline which I forgot to push to production. And now you're kind of feeling Ravi is like a really bad data scientist. I was not, or I was maybe, but then I realized, shit, I didn't do it. So like the good result I was getting in dev was not getting replicated in production, and that is very commonly known, and you might have heard of it as the training serving skew, right? So I'm like still figuring it out, this data and everything, and because I have automated everything, I had a lot of configuration issues because I did something looking it up on the internet trying to fix it, and now a lot of those configuration were not making sense for me, and I had multiple configuration issues because of that. And then I used a lot of glue code because you're like, okay, I want to have my data from this place, but I want to push it to S3, but also I want to use Lambda. So you end up using a lot of glue code because that's the fastest way for you to move ahead with this. And that's what I did at that point of time, thinking that, okay, that might be a good thing to do, right? But as you know, in machine learning, it's not always good to move so fast because like the technical depth, it has been there for some time and it has been used very often in software engineering. But in software engineering, when we are working with technical depth, what we do is like we go back, we refactor our code, we change some settings, and it's usually easier because you have like all your code in a GitHub and you have proper, not that much interactions among the code. But in machine learning it's more difficult because it has so many moving parts, and sometimes we forget that machine learning is not just about your algorithm or the code around it. It's much more complex than that. And when we try to move fast, we keep on building this technical depth, and then you have to spend a lot of time trying to fix these things. And this is not actually like adding a new feature, you're just trying to optimize your current state, because when you want to scale, you want it to be cost efficient, because at the end of the day business wants everything to be cost efficient. Even though how great it is, if it's not cost efficient, most probably that project would get killed. uh, this I didn't understand start of my career, right? Slowly, was a tough learning, but slowly I understood. And I want to share this picture, which makes a lot of sense now. So when we think of a ML system, your ML code is one of the smallest part of it, right? Uh, the bigger part, which I think we all have heard thousand times, is like a data scientist spends 80% of their time working with like data. So you take your data, data verification, feature engineering, and I kind of disagree. I don't think it's 80%. There are much more places where we put more time to it. Uh, that would be like testing our model, doing all the checking all the metadata for model, doing the different process management, doing analysis between different version of the model or different sets of the model. And then when you finally are ready to put into production, then a big heavy load of configuration comes, right? You have so many configuration for your serving phase, for your training phase, and all those things. If you are doing hyperparameter tuning, then you want to automate this. uh, you also have a lot of resource management because you don't have all the resources at your disposal. Do you want to spin up more CPUs? Do you want to spin up more GPUs? Or do you want to scale up? You want to scale down? What would be your serving infrastructure at that point of time? So these things, right? And you also want to monitor, because like if anything is in production, you want to have a pulse of how things are moving. You just don't want to leave it there. And these adds a lot of things on top of it. And one thing which I think has now becoming more and more prevalent as we are moving ahead are basically these three things, right? Security is obviously makes sense, but also the legal compliance. It really doesn't matter which part of the world you are living in. I'm based out of Europe, so we have a lot of compliances we have to follow when we are working with machine learning. So you have to make sure that whatever you're building is compliant, otherwise you can get into a lot of trouble. And it's not just because there is a law you have to do it. As a person or as a company, we also has this ethical thing where we should be transparent about how our model is deciding what it is deciding, because sometimes the output of a model could decide a fate of a human being, whether it's an insurance company or anything else. So you should be very clear. You should have things set up in a place which could showcase this, right? And you can very clearly explain, and if you see biases, you can go and improve it. Great. So I talked a lot about what are the problems, right? Let me talk you through how hopefully we can manage it, or how I have been and my team has been trying to manage these things. So let me quickly start my laser pointer so that it's easier for me to explain. Awesome. So I think this whole topic, like having a good data platform, I can speak about it for like an hour, because that's the base of everything. If you don't have a good data platform, any machine learning you do would be garbage. This has been like the case since the inception of machine learning, right? So first, make sure you have a good data platform where you are sure of the quality of data and everything. And then once you have this data platform, this will take care of the stuff which I talked about in the problem I faced, right? The data dependency. So if I go to dbt, I can see the different references, I can see the lineage, I can see how each feature in my model, where is it coming from, has it changed in the past. So these kind of having a good data platform can help you a lot with the data dependencies. And it's and it's a very important component of a machine learning infrastructure, which I feel sometimes gets overlooked. uh, then I mean, we're still doing our initial data analysis in Jupyter, which is good tool, to be honest. Like if you are at a very early stage trying to figure out things, trying to play with it, notebook is a great environment where you can still go and run a small block, see how it's outputting. But once you are ready with your notebook, what we are trying to do is, like, a good way to do would be to automate your workflow, and one way to do this would be using Flyte. So I'm not here trying to push everybody to use Flyte, but I'm just sharing my experience. This has worked best for us, given our scenario. Maybe something else for you, because there are a lot of good tools out there, so you have to evaluate for yourself. So what we have tried to do here is basically create Docker image for each of the flight tasks. So this would be my one Docker image running one flight task in dbt, which would do my data prep. And because it's in dbt, I can see the lineage and everything. Once the data prep is done, I can have my Python, which I'm very comfortable with running in a separate flight task, again a Docker image. And then you can have another image running your evaluation and validation, right? And this whole workflow, you can have a workflow config where you can define this. And Flyte has this great feature where you can parameterize your workflow. So even if you have to change your workflow here and there, small changes, uh, it can be done using parameter, which is a great way to do. And this makes the whole taking tracking your configuration much easier. Flyte also provides us with a great UI where I can see the whole workflow and I can do some input and output validation. So that works good for us. And yeah, you can have like multiple workflow running. And one of the good advantage following this approach is that even if you have worked with Python, you know that setting up the environment is a nightmare, right? You get a code from your colleague and you try to run it, and then you figure out, oh, this version of Python doesn't support this version of this package, for and those kind of things. But if you have your registry created for Docker, where you have already uploaded that image, they can download image and can get started working it with quite fast, and you can take care of those dependency there. Once you're ready with your workflow, once you feel like, okay, this is the best output of a model, you can save it at a model registry. Again, it's up to you which model registry suits best. For my case, it's a simple S3 where we are putting all our models, the trained models. And once you know this is like, okay, this is great. And obviously, because it's like everything is in Python code, everything is parameterized, and it's easier for me to work with Git, so I can have the version control on top of it, which makes it easy for me to look at my code, get peer reviews. Because like when you're working alone, you might overlook some stuff, but because it's a code, it's on Git, You can ask for PRs and reviews. That makes the chances of error less. Obviously not foolproof, but that makes it easier to understand. And once you have that ready, you can have a very separate workflow for your production, so you're not hampering your production workflow, which would again be something like a different Flyte workflow, and same way the containers, right? So you will have the feature engineering part of it done. One of your Flyte tasks could load your artifacts, and once you're done, you can use any serving architecture you want. Like here I have given example of Selden core, but it's up to you which one you want. And basically from there you can serve your model. And here, like some of the things I talked about earlier about like the whole configuration issue and this, it makes it a bit manageable, because you can set the templates, you can set the standards for this uh, workflows, and that you can share across the organization and you can work with it. And then I think one of the important part, which is like the whole communication, if you can set up an event bus among them so that they have a standard way of communicating between tasks, that would be a great help here in any case. And I think one of the most important, which like as a data scientist you would appreciate a lot, is setting up those tracking. So having a metric dashboard where you can see the different metrics related to your algorithm. uh, it could be depending upon your algorithm, ROC curve, or like mean error, or all those things. And using something like Humio for logs and resource monitoring, so you can see, okay, how much resource we have using, what are the different logs. So if a configuration is failing, now it's easier because you have the logs, so you can go to that logs and check and fix those issue. And then you can set up some monitoring with a tool like a Datadog, where you can see, has my pipeline been working, or was there a delay in the data pipeline, or was some error. And these all tools, they provide great graphical user interface, so it's easier for you to daily go and check. And when you want to go into details, you can go into the logs and get the more detail about it. So this, like, this gives you quite a good place to start with it. And I mean, you can never get rid of the technical debt, but makes you more prepared to handle those as they come, and be like, you can minimize it to the most. And the way we are trying to also do it is like, all of this containers I talked about, Docker, they are orchestrated using Kubernetes. So again, it's in code, so you can have those code in GitHub, you can review this code. And basically it's much easier to maintain than everybody running their own system. And for Kubernetes, and we are using Terraform as our basically orchestration of our infrastructure, right? So it's an infrastructure as a code, so it's easier for one team to share this code with other team, where they can replicate, and the code is again. So having these kind of approach, where you're not kind of working inside a tool but at a code level, provides us much more control over things. Uh, and when you think you are ready with all of this, and you are ready to move to multiple ML project, one great thing for anybody to look would be to have a feature store. Feature store basically will help you a lot with the initial things we talked about, like the training serving queues or entanglement. Because once a data science team has created a feature there for the model, and they know that it's good, they can put it into feature store. And there are multiple feature store in the market, or you can use your own, where it provides like the same copy for your analysis and also for development. So the chances of, sorry, not development, sorry, production. So the chances of training and serving queue reduces. And most of the feature store nowadays also have this thin layer of high velocity database. So when you're working at a real time, it always stores the latest feature value for that feature, and that could be accessed within milliseconds. So you can have real-time prediction, which could be a challenging if you want to fetch that data from a database. And then it, on top of it, obviously it had more feature, and it kind of provides this a common place where, as a data scientist, when you're starting with things, you know these are the feature created by some of the data scientists in your team, and you can reuse them. So you don't have to worry about like making those pipeline again and working towards it. So you have something already there, and it makes you move faster. One more thing which I want to say here is like, because you have this nice monitoring and you can see all the loggings, you can implement different things for like heuristic explanation and fairness. These are the things I talked about during the ethical part, right? You want to have some kind of heuristic measure, so don't just want to say this is my mean error or this. You also want to talk to business and say like, my model has this percent error, is it good enough? And just checking with the business, you should have some kind of uh, framework like Saply or anything where you can explain your model, and given that this is quite automated infrastructure, you can run it, put those graphs into one of your dashboards so people can see how the model is performing. And then you can put a human in the loop where a domain expert could sit and see those graphs and maybe say that, okay, this is not making sense and not, and blah blah blah, basically. And that's how you control the ethic parts of it, right? Or and then one thing, I was really not sure how to put into it, but I wanted to give a shout out is to use a tool like a carpenter in one of your like that would come here, which could provide you like auto scaling. So when you are doing hyperparameter tuning, you can auto scale or upscale your workflow to use more GPU. And then when you had find out those nice parameter, you can downscale to like, so suppose you upscale to 20 GPU because you're hyperparameter tuning, you can downscale to again like 2 GPU, and then you're saving cost, but you're also saving time. So these kind of thing, if you keep on mind when you're designing about your infrastructure, could actually really help you, I would say. So, coming to the moral of the story, drink a lot of water. Yeah, I was so dehydrated with all the coffee. So one thing would be obviously drink a lot of water. Another thing, like making shortcuts, because sometimes you want to just start with things. Taking shortcut would actually impact your project worse than taking the time initially to think about everything. So think about those things at the start. And it's very difficult for anybody to say how you would quantify this technical depth. And just moving fast doesn't mean you are doing it right. You have to carefully see what are the areas where you can fail and think continuously over it. If you are working in different like sprint, or if you are working in quarters, you have to put some time into refining your process or looking into technical depth. You can't put all the time just into adding new feature. You also have to currently improve on new feature. One of the paper by Google, have linked to it at the end of the presentation, has very nicely mentioned that some of the guidelines you can see to do this is like how easy it is for you to test a new algorithm on a large scale, right? So if you have these kind of workflow, you can most probably run it very easily. uh, Again, data, like make sure you have a pretty good data platform set up. uh, and basically, if you are going to change one part of your system, can you measure how it's going to impact the other? Because as I mentioned earlier, everything is quite linked. And finally is like improving one model should not negatively affect the other, because sometimes one model could be input to your another model. So you try to improve one model, but it kind of, so you should be able to see that. And those kind of matrix dashboard and the threshold, that provides you a very powerful tool to do those things. So yeah. And how easy for you to get a new team members get up and running, and it's easier to explain your code, where is the code, and all those things. Yes, I think that was what I wanted to talk about. I have added the links to the papers which I would recommend, and some books you should read, because I think this problem is very specific to each organization and each problem. So choose the solution which works best for you. And yeah, this is me. I'm working as head of data analytics at Seepstead. It's a big company in Nordic. If you're outside Nordic, I'm not sure you know about it. I worked as a data scientist at HBO, before that Tele2, and I've been working with data for last 13 years. And yeah, now the stage is all yours to ask me any question. I'm really looking forward to hearing from you guys if you have faced similar challenges, or what are your things. So I would hang around in the conference even after the talk. If you have anything, please reach out, or if you have a question, let me know.
Robbie, that was awesome and perfect timing. You left a mere 5 minutes for any questions. I see a few right here in Q&A. It looks like there might be some in the general chat. We can kind of start there, and obviously anyone who's listening, if you have additional questions or as these get answered, and again, you think of anything, feel free to post them in the Q&A. We can pull them from there.
I see there are two questions on the chat at least.
Yeah, we could dive into them within the next 4 minutes we got.
Yeah. Uh, so I think the first one is in managing technical debt slides. Some of the tools logo aren't captioned. Can you please tell which tools they are? Yeah, sure. So like the idea for me is not to tell you which tool to use, but to give you an idea. There are tools. So I can most probably let me go back to that slide and basically explain what those were. Wait, this is I have to click through it quickly so that yeah. So in terms of logging, you have Grafana, which you can use as a metrics dashboard, then Humio. We use Humio for our resource management and logs and everything. And then you have Datadog, which we also use quite a lot for monitoring our services, how they are running and everything is working fine. But I also want to stress again that I'm not saying these are the only tools you can use. There are multiple tools. The idea is that you should have metrics dashboard, you should have those logs, you should have monitoring in this place. Doesn't matter which tool you use, if that makes sense. Good. Should I move to the next one? Why Flyte instead of Airflow?
Yes, let's do that.
Yes. So I think like if you go to Flyte website, they have a pretty good blog post about it, but I will try to go over briefly in this. So Flyte is made for your data pipelines and orchestrating that. Sorry, Airflow. But Flyte is made for orchestrating your ML workflow. So it is, I would say, more polished to handle those things. And it provides some of those features where it is easier for you to build those pipelines and work with dockers and images and make it work better, because Flyte is much more focused on machine learning, I would say, and Airflow, I would say, for your data flows. So I think both tools are great and they actually work great together. So don't think of one as a replacement of other. They are complementing tools. Yep.
Awesome. With the next 2 minutes, again, if anyone has any further questions, or if there's anything, again, we can always continue this conversation in Discord. There will also be a link available in the reception area. And just a heads up that we are recording all of these talks, so they will be published soon, and you should get notified when they do go live if you want to rewatch. But Ravi, again, appreciate you greatly for the presentation. I found it super helpful. I'm sure everyone else did. But yeah, with the next 60 seconds, if there's any closing remarks, we can go from there.
No, I mean, like, I want to learn from what you guys have been facing. So I would hang around in the lounge area and I would be here in the conference event tomorrow. So I'm happy to hear your thoughts and like what you're facing. So I'm happy to present. Thanks a lot for giving me this opportunity.